Welcome. In this video, I'm going to show you how to find the area bounded between cosine and sine between x equals 0 and pi over 2. Before we begin, though, let's sketch a picture. And so I'm going to begin by sketching my x and y axes. And these curves have kind of an irregular overlap between 0 and pi over 2. So it's a good idea to have a sketch so you know what you're actually doing. Okay, so let's start with cosine x. Cosine of x will start here at the point 0, 1, and it intersects the x-axis here at pi over 2, 0. So cosine is just one curve. It looks like this. There we go. Now let's take a look at sine. I'm going to sketch sine here in pink. And sine intersects the origin, and at pi over 2, it has a output, a y value of 1. So that would be right about here. Now, where are sine and cosine equal to each other? Well, if you remember your unit circle, here's the first quadrant. Here's 1, and here's the angle. Theta equals pi over 4. Sine and cosine are both the same value, and it doesn't matter what the value is. I just know that this intersection point occurs when x equals pi over 4. Okay, so now let's figure out what the region looks like, and we want it to be between these two curves. So between these two curves, actually, and x equals 0 and pi over 2. Well, if I box this off, you'll notice I've kind of created 4 regions. So let's ask ourselves, is this first region between both of these curves? It is, so I'm going to go ahead and shade this. Okay, so let's do this again. Let's box this. Excuse me. There we go. Let's box this. And now let's talk about this region. So this upper region, is this bounded by both curves? No, it's not. It's bounded above by the line here, y equals 1. So this is not the region we want here. So let's not highlight that. This region here, well, that's bounded above by sine and cosine here, but it's bounded below by the line y equals 0, also known as the x-axis. So that's not part of our region. Finally, the last possible region we have is here. And this one is bounded above by sine, bounded below by cosine, and it's definitely between 0 and pi over 2. So this is certainly the last region we need to shade. All right, so let's go ahead and set up our area. So let's go ahead and set up this integral plus this integral here. So our first integral is from 0 to pi over 4. And then let's remember, when we were first learning how to integrate and use Riemann sums, we'd always sketch little rectangles. And this rectangle here that we sketch touches both curves when it's vertical. So that is, this is the top, this is the bottom. And we go down in this direction. So that means cosine is first and then sine. So this integral is cosine x minus sine x dx. And I'm going to rewrite this a little bit. I'm going to move this 1 here, just so I can write this as one equation. So 1 plus 2, 1 is the first integral, and 2 here is the integral representing this region. In this case, we have sine on top. See, we're traveling in this direction, and cosine on the bottom. So this is the integral, and now we're going from pi over 4 to pi over 2. Of sine x minus cosine x dx. Now, I could integrate these two regions separately, or I could just take into account that this region and this region, well, they're symmetric. They're identical. So I can really write this as double this integral or double this integral. And I'm going to choose to use this one because it has a 0, so it's going to make my algebra just a little bit easier, and that's enough for me to favor it. So this is equal to 2 times the integral from 0 to pi over 4 of cosine x minus sine x dx. Integrating yields 2 times sine x plus cosine x from 0 to pi over 4. And now we can evaluate this. So this is 2 times sine pi over 4 plus cosine pi over 4 minus sine 0 plus cosine 0. I guess I didn't need all that much more space. Well, sine of 0, that's just going to be 0. Cosine of 0, well, that's just 1. Sine of pi over 4 and cosine of pi over 4, those are both the same. This one's root 2 over 2, and this is root 2 over 2. So what we end up with is here is root 2 minus 1, and of course we can't forget that I have this 2 multiplied on the outside. So you can leave it like this or write it as 2 root 2 minus 2.